Hello, wonderful friends. Today we are asked to find the area of this semicircle. First, I want to apologize, yes, because according to the question, this is supposed to be a triangle. Yes, it is a triangle, but it's supposed to be an equilateral triangle. Okay, an equilateral triangle, and this is meant to be a semicircle. So let's assume this is a semicircle and this is an equilateral triangle. Now let's read the question. The question says, given is a triangle with an inscribed semicircle, the semicircle's diameter lies along the top side of the triangle. Now the question is, what is the area of the semicircle? Okay, first of all, we need to find what is the formula for area of a semicircle. There is no formula for area of a semicircle without knowing the formula of the area of a circle. Okay, now first, the area of a circle, okay, area of a circle is equal to pi r squared, where r is equal to the radius of the circle. Okay, pi r squared, where r is the radius of the circle. Now we are asked to find the area of this semicircle. A semicircle is half of a circle, right? If a semicircle is half of a circle, then it simply means that the radius of the semicircle should be pi r squared, which is the area of a circle, divided by 2. All right. Now, if you go to the question, you will notice that there is no radius here. The radius of the semicircle was not given to us. It was not given. But one thing we are sure of is that this radius lies along this line of the triangle. Okay, so from here to here, and from here to here is supposed to be the radius of the semicircle, but it's not given. But there is something we can deduce from the diagram. Now, look at this particular line. This arc of a circle touch this line at just one point. And if that happens, that means that this point of contact, this line is a tangent. That is, when a straight line touches a circle externally at just one point, a tangent is formed. And there is a theory about this. Now, the theory states that the line drawn from the center of a circle perpendicularly to the point of contact between a circle and a tangent forms 90 degrees. Yes. So this simply means that if we draw this line from here to this point of contact, okay, 90 degrees is formed here. That is one thing we need to notice. Okay, now also remember that from here to here is half of this line. If from here to here is 6, then from here to here is 3, right? So here should be 3. Now another thing we need to deduce is, if, like we are told, this is a this place is 6 degrees, 6 units, this is 6 units, and this is 6 units. So this is an equilateral triangle. Now remember that the sum of angle in a triangle, sum of angle in a triangle, sum of angle in a triangle is equal to 180 degrees. Now, if this is an equilateral triangle, if the sides are equal, then the angles are equal as well. Okay, so to get one angle, this particular angle, let's call one angle x. So to get x is going to be equal to 180 divided by 3, and this will give us 60 degrees. Okay, so let us draw this out now. Let's draw this triangle out. All right, and this is 90 degrees according to our diagram. Then this is x and this is 3. Okay, so this is x and here is 3. Okay, now notice that we just formed a right angle triangle. Let me draw it well. So if I draw it this way, all right, now this right angle faces this place, which is 3. So this is our 3, and this is our angle x. All right, okay, Now, let us solve. Remember that from here to here, since this line touches this semicircle at this point and is coming from the center of the circle, it means that this is our radius. Okay, yeah, so that means that this is our radius. The side facing the triangle, facing the angle, is our radius. Now, if we're able to get this radius, then we'll be able to solve for the area of our semicircle. Area of a semicircle. All right, so we'll be able to find the area of the semicircle. Now let's go ahead and solve. Remember that according to trigonometry, if we use the trigonometric ratio, this theta, okay, this is opposite, our r is opposite, okay, and this side facing the right angle is our hypotenuse. So 3 is equal to hypotenuse, and we are looking for x. X degrees is equal to what? Now, if you remember SOHCAHTOA, according to SOHCAHTOA, we simply stand for sine is equal to opposite over hypotenuse. Okay, cos is equal to adjacent over hypotenuse. Tan is equal to opposite over adjacent. All right, now look at what we are given. We are asked to find the opposite. The hypotenuse is given, so we need what we connect opposite to hypotenuse. Okay, so if you go through these trigonometric ratios, this is what connects opposite to hypotenuse. That means we can solve this using sine. Okay, so if we say sine x degrees is equal to opposite, which is r, over our hypotenuse, which is 3. So this over 1, if we do cross multiplication, the radius is equal to 3 multiplied by sine x. Okay, all right, now remember that our x is 60 degrees. So this is where we said it. X is 60 degrees. So r is equal to 3 sine 60 degrees. Now we know the value of r. Let's go back to the area. The area is pi r squared divided by 2, right? So we have area is equal to pi r squared divided by 2. So that means that we can write area to be equal to pi multiplied by our r is 3 sine 60, right? 3 sine 60 degrees squared divided by 2. So area then is equal to pi times. Now let us solve. What is 3 sine 60? I'm pressing my calculator. 3 sine 60 will give you 2.5981 approximately to 4 decimal places. Okay, so our area is pi multiplied by, now let's raise this to the power of 2. Okay, so we have 2.5981 raised to the power of 2 will give us 6.7501 to 4 decimal places. Okay, we have squared it already, divided by 2. So A is going to be equal to, remember that your pi is approximately 3.142. Okay, now multiply by 6.7501 divided by 2. Okay, area is equal to, so we have 3.142 multiplied by 6.7501. We have 21.2088 divided by 2. So the area now is equal to the answer we got divided by 2, which will give us approximately 10.6, okay, square meters. If this is the first time you are seeing this channel, please Support us by clicking the like button, subscribe to the channel, and on your notification bell, okay, so that you'll be notified anytime we upload a new video. Thank you so much for watching. See you in my next video. Bye.